Find the adjoint for this 3 by 3 matrix. All right, well, let's copy down our matrix. 2, 0, negative 1. I think the next row started with a 3. 3, 3, 2. Negative 1, 2, 0. But we'll just double check. Have we got this all right? Yes, we do. Okay, so now it's up to us to start computing cofactors. Okay, so we should probably declare what we're trying to do. So 1, 1 cofactor. I always go one row at a time, and that gets us the first column, the next column, then the column after that for the adjoint. But of course, you're more than welcome to vary. And that's perfectly allowed. Okay. So negative 1 to the 1 plus 1, determinant of the 1, 1 submatrix. Negative 1 to the 1 plus 2, determinant of the 1, 2 submatrix. Negative 1 to the 1 plus 3, determinant of the 1, 3 submatrix. So let's work these out. First row, first column, 3, 2, 2, 0. Okay. This would be a bit more annoying if it was a 4 by 4 matrix, because to find those determinants, we'd have to cofactor expand them. But these are going to be 2 by 2 matrices, so 2 by 2 determinants. We'll just use the little formula. 3, 3, negative 1, 2. Okay, so negative 1 to the 2 is just 1 times 0 minus 4. Negative 1, 0 minus negative 2. And negative 1 to the power of 4 is just 1. 6 minus negative 3. So negative 4, negative 2, and then 9. All right, so that's the first column of my adjoint. Copy our matrix again. 2, 1, 0, 3, 3, 2, negative 1, 2, 0. I feel like I'm missing a sign or something. 2, 0, negative 1 on top. Two, 0, negative 1, 3, 3, 2, negative 1, 2. Okay. Now we're good. Okay, so let's move along the next row. Cofactor expand for these. Now, do be careful. Sometimes I see people when they do this, they're so used to determinants and cofactors being multiplied that they're not paying attention to what they write. That they will sometimes take the cofactors they calculate and multiply them by the entries. Okay. Entries are different from cofactors. They combine when you're trying to calculate the determinant, but other than that, we're not so interested in them. Okay. And we don't need to write out the submatrices. We can just calculate their determinants. So eliminate second row, first column. We'll get 0 times 0 minus negative 2. Second row, second column, we'll have 2 times 0 minus negative 1 times negative 1. And then the last one, second row, third column eliminated. 2 times 2 is 4, minus 0 times negative 1. Okay. So negative 1 to the 3, we'll get minus 2. Negative 1 to the 4 is just going to be 1. We'll get 1 times negative 1. And then we'll get minus of 4 here. So negative 2, negative 1, negative 4. Those are our next cofactors. And although we sort of went along a row of our matrix, this makes the second column of our adjoint. All right, last row to go. And that'll make the last column of our adjoint. I don't know why I've stopped trying to write out the cofactor that we're working with. It's always a very good idea, if you can, tell people what cofactor you think you're computing. -1 to the 3 plus 1, -1 to the 3 plus 2, -1 to the 3 plus 3. And we'll leave some space for the determinant calculations. And away we go. So eliminate the third row. All of these will have the third row eliminated. But first column, so 0 times 2 minus -3. 2 times 2 minus -3. And 2 times 3 minus 0 times 3. Okay, so we will get 3. -1 times 7 is -7. And 1 times 6 is 6. So that becomes the third row of our, or third column of our adjoint. So what was it? 3, -7, 6. -2, -1, -4 there. Okay. And then the last one, -4, -2, and 9. All right, just double check. Did I have those right? Yep, -4, -2, and 9. So this should be the adjoint that we seek. All right. So nothing really left to say there. Yeah, there we go. We got our adjoint, showed our cofactor work. There isn't a shortcut like there is for the 2x2s, so we do have to be on our toes and making sure our calculations are all correct.